Right, live from period 3. We're going to do step-by-step on how to add and subtract rational expressions. So I won't lie to you. I could read all this stuff to you. It might just confuse you. So why don't I actually do a problem, show you the steps, I'll label everything for you. And then after that, if you guys have any questions, you can ask. Now, I'm going to try and go through like 3 examples today, and that's it, because I want to give you a little bit of time to wrap your head around things. The big thing that you need to know is if you do subtract one fraction from another, you need to distribute your negative when you're simplifying your numerator. But we'll get to that whenever the time comes. Let's take a look at example number 1. Example number 1 here, I've got x over x plus 5 plus negative 50 over x squared minus 25. First thing you want to do is factor. If it's not already factored for you. So like x over x plus 5, that's already done. X squared minus 25 can become x minus 5 and then x plus 5. Okay, so that's step 1. Make sure to factor everything out. Because what do you notice? If you notice the left side and the right, they both share an x plus 5. Okay. So the step after this is going to be find your LCD, your least common denominator. So what I said is you try and take one of each from the problem or what you're missing. So for example, my least common denominator here would be x plus 5 and an x minus 5. Because my right side has both of those, my left does not. I want to take the greatest amount. Okay, it's different from your greatest common factor, even though one says least and one says greatest. Yes. It's the least common denominator because you're looking for something that they will both have in common. It's the greatest. It's essentially like the greatest amount of factors that you can think of that both will have in common, even though it's least common. So, for example, they don't, but I can't get rid of an x minus 5 to make them the same. So the only thing I can do is add something into a problem. So that's the next step here is we're going to use that LCD to rewrite and multiply in what we're missing. So I'm rewriting the problem, and then in red, I'm going to show you, since my left side is missing an x minus 5, I'm going to multiply by x minus 5 on top and x minus 5 on bottom. So remember, whenever we're trying to combine our terms, we want them to have the same denominator. So now let's combine. So I'll have x minus 5 times x plus negative 50 all over x minus 5 times x plus 5. Number one mistake that students make from this point, okay, just being real with you, they see x minus 5 on top, they see x minus 5 on bottom, and they go, done. Okay, cannot do that. We just put those into the problem. We don't want to take them back out. So we definitely don't want to do any type of simplification for the bottom. Leave the denominator like it is the whole entire way through. So all I did was, in order to multiply those together, I combined the top, put the plus in the middle, so that's what gives me my top. And now since they both have the same denominator, I just put that one time in the bottom. For example, let me put it to you in simpler terms. What's this equal? Okay, how'd you get it? Okay, so how do you add them together? Okay, over, why didn't I write 2 4s? It's the same exact thing down here. It's the same exact thing. Why write 2 4s? So we don't want to write the denominator twice. I'm just showing you guys because I think that makes it a little more clear as to why we don't do that. So from here then, okay, up through, okay, we want to simplify the top. Simplify the numerator. So I'm going to have x squared minus 5x minus 50 over x minus 5 times x plus 5. Again, I don't do anything to the bottom. Once you have it factored, just leave it the whole entire way through. You could write that as x plus 5 times x minus 5 on the bottom. That's fine.
No, I always talk about for the top.
Oh, for the top, yeah. We want to try and factor the top again, if we can. So what's going to multiply to give me negative 50 and add to give me negative 5? 10 and 5. So x plus 5, x minus 10 over x minus 5 and x plus 5. And then they both have an x plus 5. So my final answer would be x minus 10 over x minus 5. And that's it. Okay. That's why I'm trying to create this video for everybody, is because there are quite a few steps. Now, some of you are a lot smarter than me. You probably skip a couple steps, but it's going to be a little difficult. Yeah.
You didn't get the negative 5 that we put in.
Yeah, I left the bottom the same, but I had an x plus 5 and an x plus 5 in that previous one, so I had to cancel them out. Yep. How do the signs work? They would have to add to get negative 5 and multiply to get negative 50. Yeah.
I thought you said how science works.
Okay. Questions? Any more questions, Jack? Whenever she gets back. All right. Let's take a look at example number 2. I'm going to show you example number 2, and then we'll go through 3, and then that'll be it for today. All right. First step, again, factor. So the bottom here, I can pull out a 3. And then here, x squared minus 1, that's a difference of squares. So I get x minus 1 and x plus 1.
So would it be x plus 1 over x plus 1?
So my LCD would be 3 times x minus 1 times x plus 1. So the way the LCD works, scan from left to right. What my suggestion is write what's, for your LCD, write what's in your first, write what's in your left side in your denominator. And then if you see something different in your right side, that also goes in your least common denominator. So for instance, the right side already had an x minus 1. We already put that. So then the x plus 1 would go there too. Okay. So now I'm gonna rewrite this here. That's all I'm doing. And then in red, I'll show you what I've got to multiply each of these by, so they have a fraction that you can use. All right. So this left side, I am missing an x plus 1. And then on the right side, it looks like the only thing I'm missing is the 3. So I'll multiply by 3. So now let's combine. I've got x plus 1 times x minus x times 3. I'm just going to write it as is. I'll rearrange stuff in a minute. And then down here, I'm just writing my LCD. You can write this in any way if you want to. Usually the 3 goes out front just because it's just a single number. But the x plus 1 or x minus 1 are definitely interchangeable. Okay. Let's simplify the numerator. So I get x squared plus x minus 3x over 3 times x minus 1, x plus 1, which then becomes x squared minus 2x over 3 times x minus 1 times x plus 1. Okay. Last thing we want to see is if we can factor anything in the numerator. It looks like you could take out an x if you wanted to, make this x times x minus 2 over 3 times x minus 1 times x plus 1. And there's nothing on top and there's nothing on bottom that are the same. So that would be my answer. Yes. Yeah, I'll keep that up there for a minute. Okay. I want to do one more example for you. And then after that, that's pretty much it for today. All right. Example number 3. Last example for today. X plus 5 over the x squared minus 7x plus 6, and then so forth. Let's go ahead and factor. See if you can factor. Wow. All right. Hopefully you were able to factor the bottom. What's going to multiply to give you 6 and add to give negative 7? That's negative 6 and negative 1. And then x squared minus 36 is the difference of squares. Least common denominator. Does anyone know what that would be?
The x minus 6, x plus 6.
X minus 6, x minus 1, and then x plus 6. Or any combination of those. You'd want all 3 of them in there. They both already share the x minus 6, so you don't need to worry about that. So they both share an x minus 6. Okay. This one has an x minus 1 in it, so that has to be a part of our LCD. Okay, and then x plus 6 also has to be a part of it as well. Yeah. So I'm just gonna rewrite this. Okay. And on the left side, it looks like I need an x plus 6. So I'm going to multiply that. And then on the right side, it looks like I need in my denominator an x minus 1. I'm going to combine. So I'll have x plus 6 times x plus 5 plus x minus 1 times x minus 1 all over. And then it doesn't matter which order you put these in. Just need to make sure that you have them all. Okay, so when I simplify my numerator, I'm going to have to FOIL the left and FOIL the right. So remember, first, outside, inside, last. This will become here x squared plus 11x plus 30. Okay, x times 5 gives me 5x, 6 times x gives me 6x. They had to give 11x, and then I multiply 6 and 5, and I get 30. And then on the other side, it would be plus x squared minus 2x plus 1. X times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. That's how I get negative 2x. And then negative 1 times negative 1 is positive 1. And then all over the x plus 6, x minus 6, and x minus 1. And then I'm going to simplify the numerator a little bit more. I've got an x squared and an x squared I'm adding. So I've got 2x squared plus 9x plus 31 over x plus 6 times x minus 6 times x minus 1. Now, is there anything that's going to multiply to give me 2 and multiply to give me 31 that's going to add to give me 9? No. So I'm done. I can't simplify that top part, and then that's my final answer.